Okay, so today I'm speaking with Stephen French. He's a professor of philosophy of science at Leeds University, so he's not far from me. He's the author of 6 books and over 90 papers, and he's the former president of the British Society for the Philosophy of Science, and he's the co-editor for the British Journal for the Philosophy of Science. How are you, Stephen?
Fine, thanks. Yep.
One of those books, one of the 6, is there more than 6 now, or is it still at 6?
I think it's more than 6 because I've got a textbook out.
Oh, okay. What's the
It's,
title?
Philosophy of Science, Key Concepts.
I'll put the description of that below. If you're listening to this, go and check that out. One of your books is The Structure of the World. A really interesting book.
Yep.
Again, I'll put the link to that below as well. I've already shared that on social media, but I'll put the link below. And in it, you argue for an Ontic structural realism. Now, could you first give whoever's listening a good in-depth idea of what Ontic structural realism actually is?
Right, so, I mean, a good way of expressing it is captured by the phrase that James Ladyman used in his first paper where Ontic structural realism was presented, which is in 1928. And whereas older generation of structuralists like Bertrand Russell and John Worrell had argued that all that we know is structure, James put forward the claim that all that there is structure. So the argument, the position is basically that the world is structural in some sense, and obviously articulating that sense is where all the details and all the difficulties lie. In his Stanford Encyclopedia article, James expresses structuralism quite broadly as a view that prioritizes structure and relations over objects. And so there are versions of Ontic structural realism that retain objects but kind of downplay them ontologically. My version is a more radical version, and it basically argues for the elimination of objects in favor of the structure.
The elimination of the objects. Now, that's a very interesting claim. What are some of the arguments that you use to support that?
Okay, so here's how it goes. So the first sort of broader context is a kind of naturalistic metaphysics that says something like this. What we tend to do is we take the metaphysics that's been developed of sort of everyday kinds of entities, tables, chairs, people, and so on, and we try and export that into the domain of physics, into the micro realm. We try and develop a metaphysics for physics based on that kind of everyday metaphysics. And the core claim of my form of Ontic structural realism is that just doesn't work. Right, and a number of people in the past have noted this. Ernst Cassirer, the great neo-Kantian philosopher, noted this. Arthur Eddington, the great physicist who confirmed Einstein's theory of general relativity, he noticed this. And so the struggle is then to develop an alternative metaphysics. But here's how it doesn't work. Here's one way it doesn't work. You try and take the ordinary metaphysics of objects with properties, and you take that into quantum physics, and then you discover that quantum particles don't behave statistically like ordinary objects. Their aggregate behavior is very different from that of classical objects. The actual statistics is very different. This is what leads to, on the one hand, something called Bose-Einstein condensation. It gives us lasers and so forth. It also, on the other hand, explains the behavior of electrons and other kinds of particles that basically give us properties like the solidity of tables. So this is important stuff. But the statistics indicate, or seem to indicate, that these objects cannot be regarded as individuals. It turns out that you can create a metaphysics of quantum objects that do treat them as individuals. Right. Well, now you've got a kind of problem, right? Now you've got this view. You've exported the metaphysics of objects into the realm of physics, and it seems you've got a choice whether to regard them as non-individuals or individuals, and the physics can't tell you which one to go with, right? You can defend either. Now, if you're going to be a realist about quantum objects, it seems to me you owe an answer to the question, all right, are these objects of which you speak individuals or non-individuals? This makes a crucial difference. If you're a sort of metaphysically inclined realist, you should give an answer to that, and you can't on the basis of the physics. So my version of structural realism says, look, just retreat from that underdetermination. Just cut out the objects. Just look at the relevant structures, and in this case, it's a structure given by something called the permutation group, which tells you how the particles are permuted between states. That's what you should be focusing on. That's where you should put all your ontological attention on, and just eliminate the objects. Okay? Now, eliminativism seems to get people very nervous for reasons that I don't quite understand, I have to be honest. There are devices that you can borrow or steal, if you like, from metaphysicians that will accommodate eliminativism. So one thing people worry about is, well, if you're saying there are no objects, how can you talk about tables and chairs and such like? And there are versions of truth maker theory that allow you to express truths about tables and chairs whilst admitting that the truth makers of those statements are not tables and chairs. And you can do the same thing with objects in quantum mechanics. So I think there's a strong motivation for being a limitativist about these objects. And then the next step is to find the relevant kinds of metaphysical devices that will allow you to express that eliminativism without alarming too many people, basically.
And do you see any large problems stopping that from happening? Do you see, because that argument that you've just laid out seems very interesting, and it also has many positive points. Is there anything that halts you?
I haven't. Well, look, I think there's an obvious problem in the sense of right, okay, fine. If you're going to do that, you need to give us a metaphysics of structure, because we're familiar with the metaphysics, or reasonably familiar with the metaphysics of objects and properties. Right? We can talk about objects as having primitive thisis or hexaety. We can talk about them as having a Lockean substratum. We can talk about properties as universals, instantiated by or in these objects, and so on. The metaphysics is kind of ready-made. But if you're going to drop all that, then the challenge for the structuralist is to articulate a metaphysics of structure. Now, some, in a sense, refuse the challenge. They say the structure I'm concerned with is just whatever physics gives us. I think we owe it really to philosophy to say something about what that structure is in metaphysical terms. Some structuralists disagree with that, as I said, but again, I think there are kind of metaphysical devices for accommodating that. You can take some of the moves that monists adopt in talking about priority of existence, monism, and so forth. In terms of dropping objects, I don't think there are any sort of insurmountable obstacles, except for the one that you've mentioned, which is how you can have relations without relata.
What about the application of mathematics, the philosophical problems behind that? Does that not give you any pause at any point?
No, it doesn't give me any pause, but that's because I maybe have a bit of a crude view of the application of mathematics. I think, look, there is a worry in that the kind of structures that the likes of me tend to point to are the kinds of structures that are presented mathematically, right? So when it comes to quantum statistics, the core sort of feature of the relevant structure has to do with the permutation group, which is a sort of mathematical entity. And so there's a risk there, and of being accused of being some kind of Platonist or Pythagorean structuralist, that you think the world is made up of mathematical structure. There are structuralists who think that. So there's a physicist named Tegmark, who actually adopts that view, and he presses it quite forcefully. James Ladyman and I have always resisted that. There are ways in which you can articulate the claim that the structure you're concerned with is physical structure. It just happens to be represented by the mathematics within the physical, within the physics. It's physical structure because basically it's tied to things that we observe, measurement results. You can try and make the distinction between physical and mathematical structure in terms of the causal features of physical structure, but causality gets problematic when you're talking about quantum mechanics. So I don't see any particular problems with the application of mathematics, except that, at some point you have to say, look, what I'm talking about is physical structure and not mathematical structure.
Why is the history of theories, the ontological history of theories, why is that a problem for the structuralist?
The kind of structuralism that John Worrell presents, which is sometimes called epistemic structural realism, was articulated as a response to the pessimistic meta-induction. The idea that throughout the history of science, ontologies have come and gone. Our view of how the world is has changed radically, so that the realists can't really claim that there's any commonality. And on that basis, cannot be assured that what our best theories are presenting to us is actually the way the world is. It's a kind of, well, as it says on the tin, it's a pessimistic meta-induction about with regard to our current realist stance. Claims we have no grounds based on the history of science for asserting that our best theories tell us how the world is. So what the structural realist like John Worrell wants to say is, yes, there is this common element running throughout the different theories that has to do with the structure. So what do you mean by the structure? Well, take, for example, and here's the example he gives, take light and electromagnetic radiation. Light is identified as a form of electromagnetic radiation. Fresnel's equations for light are recovered within Maxwell's equations of electromagnetism. Maxwell's equations are recovered within quantum electrodynamics, and so on. So if you can articulate that structural commonality, then the history of theory change is not such a problem for the structuralists. Indeed, people like Worrell will say structural realism is constructed precisely to deal with that kind of theory change. The problem comes in when you consider the switch from classical physics to quantum physics. There you have kinds of changes that aren't quite so easily accommodated as with the Fresnel and the Maxwell's equations case. So I don't want to get into all the technical details, but some people have seen the classical quantum transition as a major problem for all realists who believe that there's some sort of retention of parts of earlier theories. Simon Saunders, many years ago, in I think the first book I co-edited with Harmke Kaminka, who's sadly no longer with us, he published a really nice paper in which he compared the kind of dynamical structures of classical and quantum physics, and he had this lovely phrase that he used, that he coined, the heuristic plasticity of certain elements of the classical dynamics, the way in which these elements are twisted slightly or modified slightly, and then they reappear in the quantum case. So I think you can make a case for a kind of continuity between the classical and the quantum. We just had a conference up here at Leeds, and one of the presenters was a guy now at Bristol, Karim Tebolt, and he's got a really nice paper in the British Journal for the Philosophy of Science where he talks about the underlying common structure of classical and quantum physics. So again, this reinforces the kind of, what I think is, the motivation for structural realism. If you stop thinking about theories in terms of terms that refer to objects, and if you start thinking of them in terms of certain underlying structures, you can see all kinds of commonalities that the realist would otherwise miss, and which really, I think, block this anti-realist move that hinges on the pessimistic meta-induction. That's not to say, though, I've had a critic of structural realism, Octavio Bueno, a former student of mine. He's pointed out, look, it could well be that we get abrupt changes in the structures we use. Now, I've not yet seen examples of that, for the very good reason that physicists tend to be quite conservative for obvious reasons. They tend to build on what they already have as far as they can until they have to drop it. And so, going forward from quantum physics and general relativity to some form of quantum gravity, you might expect certain kinds of structures that you find in quantum physics retained in the new theory of quantum gravity. But that remains to be seen, right? This is a fallible position. I'm not, going to be able to predict the future progress of physics. If I could, I'd be helping myself to a Nobel Prize. But with that caveat, I don't see the history of theory change as a problem for structural realism. On the contrary, I see it as supporting it.
You mentioned a paper that compared certain similarities between the underlying structure of classical and quantum mechanics. How is that argued?
So this is a paper by Karim Tebolt in, I think that's how you pronounce his last name, in the British Journal for the Philosophy of Science. He was a student of Dean Rickles, who was a student of mine, so there's kind of a family relationship there. And he pointed out that if you look at the kinds of structures that I talk about in my book, it's not easy, to say the least, to discern the kind of commonality between classical and quantum physics that you'd really be interested in. So he was basically saying you need to look at certain dynamical structures or dynamical features of structures. And he comes up with this, generalized classical quantum structure. It involves, I don't want to get into too much into the details, but it basically involves a certain kind of space, a symplectic space, on which you define a certain algebra, basically a Lie algebra, and in those terms you can then start to identify the common structures between classical and quantum physics. And it makes it, from the point of view of the history of science, it kind of brings out really what the great quantum physicists ultimately were doing, how they were taking certain classical features or features of classical physics, and as I said in regard to Simon Saunders' paper, kind of twisting them or modifying them, exemplifying their heuristic plasticity and coming up with this new structure. In some senses, of course, it's revolutionary, right? The shift to non-commuting observables in quantum physics. This is a major move. But to emphasize that revolutionary aspect without realizing the commonality misses out not just historically, what was actually going on. It sort of misses out the move. It obscures the moves that the physicists were making, but it also obscures this underlying philosophical point that, as the structural realists would emphasize, what was going on was, in effect, a kind of closer approximation to the actual structure of the world.
Regarding this Ontic structural realism, You've given us many good arguments for it and many good rejections of the counter-arguments. What's the next move for it? How do you see it progressing?
Well, one way I see it progressing is in developing the metaphysics, right? So after I published the book, I was sort of like, done with that. I can't see that I can add any more. And since then, I've had a number of interesting, critiques and analyses from various people. Kerry Mackenzie, another former student of mine, she's published some critical papers where she says, the notion of dependence, the idea that features of the structure are dependent upon one another, properties are dependent on symmetries and so on. The way I've expressed that dependence, she says this is, problematic. You don't get the relevant asymmetry out, and she's presented a slightly more moderate form of structural realism. Johanna Wolff, I think she's currently in Hong Kong. She's about to move to London, to King's. She's come up with some interesting, metaphysical concerns along similar lines. I just got a paper a month or so ago from Donica O'Connell, who's working up in Helsinki, where he really develops this critique that you mentioned about relations without relata, and then suggests more positively a comparison between structuralism and priority monism that Jonathan Schaffer defends. That's something that I was already interested in. I've already presented something on that to the APA. Those are the kinds of things that, in those metaphysical directions, I see a lot of opportunity to develop Ontic structural realism in interesting ways. I think there's also interesting developments in taking it forward into other areas of physics, looking at string theory from this perspective, for example, or looking at quantum gravity. One of the books you mentioned was a co-edited book with Dean Rickles and Juha Saatsi, where we invited contributions on the theme of structural approaches to quantum gravity. I think I don't see myself as contributing much along those lines. I think it takes a lot of work to get to grips with the relevant physics, and I feel a bit too old for that these days. But I think that is very interesting. But for myself, as I said, I'm primarily interested in developing the metaphysics more and making. I think the book suffers because the metaphysics isn't fully developed. So many people find it implausible or not convincing because they don't have a clear metaphysical picture. I would like to think that in responding to some of these critiques, I could, I or other people could make that picture clearer and then, hopefully more plausible.
With all of these progresses, do you think that a structural realism could help the science?
Yeah, look, I mean, this is always contentious, right? Because you want to be careful and not, you don't want to get into the old normative view that philosophy of science is there to tell science, what it should do, how it should behave methodologically. That old Popperian view, I mean, that's been dropped, and typically, in my experience, physicists in particular react very badly to being told this is what you should believe, this is what you should do.
Yeah.
I think it's less so in the biological science. I think in biologists are more comfortable working with philosophers or talking to philosophers and listening to philosophers. But having said all that, again, in the book that I co-edited with Dean and Juha, we had contributions from people like Lee Smolin and John Baez, who's a great mathematical physicist. Lee Smolin, great physicists working on quantum gravity, and they were very interested in structuralism. They thought that this was offered a way in which physicists could conceive of or see the world that would free physicists themselves from certain ontological or even implicit ontological presuppositions. So I think it's at very least conceivable that Ontic structural realism could help pave the way, in some sense, to new physics. I'm not going to set too much store by that, to be honest. I think, physicists will do what physicists do. But, if, some of them, like some of the students we've got here at Leeds in physics, pick up on this idea that what we should be focused on is structure, and it enables them to reconceive general relativity or think of quantum gravity in a different way. Fantastic. Look, there's a historical precedent for this. Arthur Eddington was one of the, not only a great astronomer and as I said, the guy who for many people confirmed Einstein's general theory of relativity. He developed this structuralist picture based on his understanding of general relativity. On that basis, in his very last work, he struggled to find a form of quantum gravity. Now, I don't want to oversell that, because he didn't have the metaphysical skills and devices to make his view of quantum gravity plausible. But if you delve into that final book of his, you can see how his structuralism guided his physics. It would be great, it would be really nice, to say the least, if future physicists read some of this philosophy, read James Ladyman's Stanford Encyclopedia piece, and perhaps that helped guide them in developing a new kind of structuralist quantum gravity. Who knows? I mean, that's not for us to predict. But I think, as I said before, people like Lee Smolin, John Baez, and others have certainly been interested and have talked to us about some of these ideas.